key point on an exponential. It is always 0, 1. 0, 1 will always be on an exponential. Now, if you start adding or subtracting numbers, it starts shifting it up and down, left and right. So now if I plug in a 1, this is 3 to the x, so 3 to the first power would be 3, right? 3 to the second power, 3 squared would be 9. 3 cubed, oh, it's not going to fit on my graph, is it? Nope. 3 cubed would be 27, so I got to start going backwards. So let's plug in a -1. If I plug in a -1, 3 to the -1 is 1/3. Everybody good with that? Because you drop it down, right? 3 to the -1 is 1/3. So what is 3 to the -2? Yeah. What?
Would it be 2? No.
3 to the -2 so we're plugging in numbers here. We did 3 to the 0, that's 1, so that's a 0.01. We did 3 to the 1, that's 3, so we plugged in a 1 and got a 3. We did 3 squared, got a 9, plugged in a 2, got a 9. But then it got too big. 3 cubed is 27. That's off the graph. Okay? So what I said is we got to go smaller. So we got to go back to like -1. This would be 1/3. Right? So I have -1, 1/3 for one of my points. 3 to the -2 would be 1/3 squared, which is 1/9. You're definitely going to see the pattern here. Now look at my pattern real quick. 1 was 3, 2 is 9. -1 is 1/3, -2 is -9. So without thinking about it, if I followed the pattern, 3 to the -3 would be 1/27. Okay? It will always follow that pattern right there. The negatives always just put a underneath 1 on those. All right. So the key point of all graphs, almost all these graphs, until you start adding and subtracting and doing different things, have a 0.01 because anything to 0 power is 1. Okay. The asymptote is going to be y equals 0. Until these change, I'll put my caveat here, right here. These change if you add or subtract. Okay, so if I start adding, if it becomes like 3x plus 5, then it's going to change a little bit. Or -2, like on this outside, like if I start adding or subtracting or something like that, it is going to change my number there. All right, so back to this. We had 1/9. So now I've got 5 points. I should be able to just click the button and it will draw it. I don't think it'll do a different one than that. So this is just like the table, basically. You just have to plug in points. You will have to plug in some negatives, so you will have fractions. So use that plot a point thing. I don't think they'll put negatives in here on you. Sorry. That's the one I keep clicking the button. Stop clicking the button. If you have 1/4, again, you can always start with your y asymptote. It is going to be 0, 0 on these. I should have looked at that graph for a second, and I didn't. Hold on, let me go back and look at that one that we just did. This graph right here, you can see where the asymptote is because it starts to get flat right there. So even if you didn't add, that's why it says the directions say plot the 5 points and then draw the asymptote. You can tell where the asymptote is going to be because where it starts to get flat right there is where your asymptote is going to be. That's the spot that it's not going to cross, okay? On this one, to plot these points, you can still do 0, 1. If I plugged in a 1, it'd be 1 to the 1/4. Right? Was that what it was? 1/4, okay. 1 to the 1/4. If I plugged in a 2, any guesses what a 2 is? If I square 1, 1 squared is 1, 4 squared is 16, 1/16. We'll go the other way now. Okay. Sorry, I'll rewrite these real quick. 4 to the, oh, it was 1/4, wasn't it? 1/4 to the 0 is still 1. So that's 0, 1. 1/4 to the first power is just 1/4. So we plugged in a 1 and got out a 1/4. 1/4 squared is 1 squared and 4 squared, which is 1/16. So we plugged in a 2 and got 1/16. So now that you've done like 0, 1, 2, it is going to be the opposite, just like we just did. If negative 1 is 1/4, what do you think 1/4 to the negative 1 is? Any guesses? 4. Like it's just going to flip it. So it's going to be negative, or 1 to the negative first and 4 to the negative first. So you move it up and you move it down. So it would be 4. So let's see my pattern here. If 1 is 1/4 and negative 1 is 4, so 2 is 1/16, what do you think negative 2 is going to be? 16. So negative 2 will be 16. And if you need to work it out, that's fine. 1 to the negative 2, 4 to the negative 2, make those positive. It'd be 4 squared over 1 squared, which would be 16 over 1. All right. That was a negative right there. So plot my last points here. Negative 1 was 4, and negative 2 was 16. Now, I don't go super deep into these graphs right here. We just kind of introduce them. If you get into finance or calculus or things like that, you definitely look more at these. But what I do want you to notice here is that when on this one, we had 3 to the x, right? And it went up. That means it's going to go up 3 times as fast. On this one, we had 1/4. It actually goes down. It doesn't mean it goes up 1/4 as fast. So our rule here, just to write it out, is that if I had the formula f of x equals b to the x, if b is greater than 1, it is going to have an exponential growth. Okay, it is going to have an exponential growth. If b is between 0 and 1, which means like a fraction, I'll say a proper fraction, so like 2/3, 1/4, 4/5, 7/16, whatever, it is going to have an exponential decay. So that is kind of the weird thing about exponentials, is it doesn't be like, okay, if it's a positive, it's gross, if it's negative, it's decay. No, it's not that. It's based on that number. If it's a whole number, it's going to have exponential growth. And if it's between 0 and 1, like a fraction, then it has exponential decay. All right, finding the domain and range. Oh, this one you just got to look at it. This one shouldn't be too bad. Oh, we don't even have to use, we get to use inequalities too. So we don't even have to use an interval notation. Okay, so the range, remember the range is your y's. Whoa. My range is my y, my domain is my x. So my range is how far left to right. So the furthest point left is it does go to negative infinity because it keeps going to the left and it keeps going to the right forever. The range is usually negative infinity to infinity on these. The domain is how far my x's are, so that's how far down to up. I know it sounds weird to say down to up, but I want to know where my bottom of my graph is. The bottom of this graph is always your asymptote. So it does not touch -4, so I use a parentheses, and it goes up forever. Oh, I said right before I started that it does inequalities, so we don't even have to do all this. we don't have to do the interval notation. So what they say here is this is all reals. It could be all real numbers, negative infinity to infinity. It could be anything. And this one we would do x is greater than -4. Why'd I put like 2 negatives there? Okay. So on that one, the keys there is that your range is probably going to be all real numbers almost every time. And then your domain is going to be, the bottom of it will be the asymptote. All right, if you were transforming one of these, you use the same rules that we used before. Does it keep the original there if I do it? No, it does not. Okay, so I would base everything on this point. I like how Alex does that at point on that 0, 1. So if I am, remember the negative on the outside flips it up and down, and then the positive or adding on the outside adds or moves it up and down. So anything that's done on the outside does something horizontally, vertically. So on this one, what I'm actually going to do first is I'm going to flip it up and down, and then I'm going to move it up 3. So I move that red dot up 3. Should be at -2. Okay. So now I find the domain and the range. Did I do that domain and range backwards on the last one? Why didn't y'all stop me? I just did it backwards because it had range first. That is definitely backwards. I wrote Y next to range, and then I wrote left to right. Oh, my goodness. Okay. Scratch all that I just said there. At least I caught it before class ended. I'm losing it. Okay, so the domain here is how far left it goes. That means it's time to quit, right? How far left it goes. It goes forever to the left. The domain, how far right it goes, is going to keep going forever to the right. The range is how far down to up it goes. The bottom of this looks like it goes forever to the bottom, but then it does stop. It never actually touches 3. Okay, never actually touches 3. All right, my goodness. I don't know what I was doing. So again, that negative right there, if you look at that negative, what they say is reflects across the x-axis. And then this one moves it up 3. Okay, just to clarify, this is left to right.
Does it move the asymptote up 3 or the essential point?
Both.
It just looks like you moved it up 2 times.
Did I move it up too far?
No, just 2.
But I reflected it first.
Okay.
Let me go back after I write this down, and we'll make sure. Because obviously I'm prone to make a mistake this morning. It's Monday morning. All right, I did click solve, so that is the answer. But just to go back to here, so we reflect it. So it goes from 1, 0, and it goes to -1. And yes, you can base it like the arrow, the little cursor thing here is based on the asymptote. So it's at 0, so I move that asymptote up 3. But I should also move that point up 3 as well. So it would go from -1 to 2. So that's the thing, you got to reflect it first. That one's very similar. You just move it down. All right, so these shouldn't be that bad. Oh, wait, that one, you got to move to the right, too. So this one, remember, you move to the right. So the first thing I'm going to do, HSRV, you move it to the horizontal to the right 2 first. So I take this point and I move it to the right. I'm at 0, and then I need to go to 2. And now I reflect across the x-axis. Okay. And then my range, don't mix those up like I did, is -infinity to 0, and -infinity to infinity. Okay. So on this one, again, we reflect the x-axis. But the first thing I need to do is this one does the opposite of what you think. It moves it to the right too. So I do this first. It doesn't matter, I don't think, actually, on this one. The last one it kind of did. Real quick, just for my note-taking purposes on my webpage, let me go back and do this one real quick. Can't believe I did that. Make sure we're all on the same page too, though. All right, so the range is my y, and that is down to up. So the lowest number this can be is -4. So y always has to be greater than -4. I messed that all up because I put x on both of them. Y always has to be greater than -4, right? My domain is my x, so that's left to right. And it is going to be all real numbers. What is it? I think it just says all reals. Okay. So, to back up, the domain is the one that's always all real numbers, negative infinity to infinity, because it always goes left and right. I don't know what I was doing. My goodness. What time is it? 8:56. There is 2 topics with the logarithms. Let's just look at them real quick. I don't think they'll take very long to do because they work the same way. Translating the graph of a logarithm. The logarithm and exponentials are inverses of each other. Okay. All you're going to have to do is move this one up, down, left, right. But they are inverses of each other. Since they are inverses of each other, just write that real quick right here. She kind of said it just a second ago. So with exponential, your key point was 0, 1. With logarithm, since they are inverses of each other, your key point is 1, 0. Because you flip them when you do inverses. Okay. So, this one starts at 1, 0. I'm going to move this up 3. Actually, I move it to the left 2 and then up 3. Left 2, up 3, and that should be my answer. Okay. So everything's based on that 1, 0. I believe all they're going to make you do is move this one up, down, left, right. So this would be left 2, up 3. Left 2. Did I move that? No, that's right. Left 2, up 3. Left 2, up 3. Okay. So your key point here is 1, 0. And then the last topic, and I'll tell you why we did 2 modules today in just a second. Graphing a logarithm. It says to do this, plot 2 points on the graph of the function and draw the asymptote. We'll click solve real quick here, and then we'll go do this. The way you want to do this is to plug in points. This one is probably one of the most annoying ones because you just got to plug in the points and work it. But one point should always be, we'll have to look. I would plug in a 1, plug in a 1 always. So y equals, or g of x is fine. G of 1, if I plug in a 1, what this is saying is 3 to what power is 1? And that should be 0. You got the negative, but that doesn't matter on this one. Okay, that negative is a little bit annoying on this one. So to plug in another number, starting with a negative is not fun on this one. What I would always do on this is I would always plug in whatever this number is right here. If you plug in that number right there, it should be 3 to what power is 3. So it plugs in a 1, but since you have the negative out front, your answer is actually -1. Does that kind of make sense? Since you have the negative. And that's, I think it would be, just sort of going back, it would be better if I wrote y right here. Because this is like y equals negative log 3, 1. And then so this is the inverse. This is where my brain went when we were talking about logarithms all day. The range on this one is negative infinity to infinity on all of these because it's always going to go up forever and down forever. But then my domain, the asymptote also flips. My asymptote on a logarithm is x equals 0. Okay, it is a vertical line because everything flips on the logarithm one. Paste. Okay, so I'll go back and write that up here real quick. Your asymptote on this one is x equals 0, vertical line. Let's refresh this real quick and I'll be done, just to make sure. Kind of all had that. There's one. So on this one, just seeing how it changes, graphing it. Again, what you want to do is plug in like a 1 and a 0. So if I do y equals log 4 of x of 1 plus 3, this would be log 4 of 4 equals y. So this is saying 4 to what power is 4? That's 1. Okay. And then if I plug in a 0, I don't want to plug in a 0. I want to plug in a I want to plug in a -2. I'll say y in just a second. Log base 4 of 1 equals y. So y, 4 to what power is 1? That would be 0. So I have the point 1. My goodness, go away, ruler. I plugged in a 1 and got out a 1. I plugged in a -2 and got out a 0. Okay. Now, why did I plug those in real quick, and then I'll be done, sorry. I plugged in, why did I pick those? Because I want, what I take the log of, I want that to equal 1. If that equals 1, then my answer is going to be 0. Okay, right? So that's why I plugged in a -2. And then I plugged in a 1 because I want it to be 4. So I'm trying to make this be equal to 1 and 4. I want that to be equal to 1 and 4 to make this come out real easy. If I make that be equal to 1 and 4, then my answers are going to come out as like 0 and 1. Does that make any sense at all? Like and I'm trying to do 4 because it's base 4. Okay, we can definitely hit that again if we need to.